Hello everyone. Now please let me introduce our POI conflation framework, which consists of 5 main steps. Step 1, data pre-processing. We start by uploading the data into PostGIS. This is because PostGIS supports both B tree and R tree indexes, which greatly improves processing efficiency. And then we'll circle to remove POIs with empty names or meaningless symbols. And step 2, initial matching. We perform initial matching based on exact name and close spatial distance. These high confidence pairs will later support category distance calculation. And step 3, feature engineering. We begin by generate dense vectors for POI names using the pre-trained BGE-M3 model. These vectors capture semantic meaning and are stored in PostGIS. This step was done on Kaggle actually due to the need for GPU resources. And in PostGIS, we can view the semantic vectors stored in the relevant column. And next, we built the category distance feature. First, we map the connections between two different classification systems, and we use PML values to represent how strong those connections are. The calculation itself isn't too complicated. So let's take a look at the results to get a better intuitive understanding. For example, if two categories only appeared twice in the initial matching data and both were one-to-one matches, that means the connection is quite strong. You can see several similar pairs below. And let's take a look at other samples here. The category show up tens of thousands of times in the dataset, but only match once, which likely means it's just a noise. So this approach helps us figure out which category pairs truly match and which ones are probably mismatches. And we then visualize these connections as a graph, where each green line is a bridge between two categories, and the number of steps in the graph serves as a mirror of category distance. And we also calculate sparse vector similarity using the BM25 model. To do this, we first build a bag of words for POI names and addresses. And the final feature actually is spatial distance, which is computed in real time using PostGIS. Similarly, cosine similarity between dense vectors is also calculated on the fly. And step 4, we use nearly 1,000 manually labeled POI pairs for supervised learning. And we compute features and train a random forest model, which performs significantly better than traditional Levingston distance-based models. And also, from our perspective, POI conflation also involves searching, not just matching. Starting from a POI, we retrieve candidate matches and then use the random forest model's prediction probability to select the best one. And to balance accuracy and performance, we gradually expand the searching distance. Yeah, as you can see, our model performs well in both tests, and actually, this benchmark we believe should be a standard in this field. And the final step is fusion. Yeah, this is the fusion result. And demonstrative logic, we create several samples records, and this is named Fusion. As you can see, we try to keep all meaningful information from sources. And this is also similar to address. We add province, city, and district information in address. And for coordinates, we use the geometric median points, which is more robust to outliers than the centroid. For category fusion, we compared the fields the name with the original categories and select the closest one. For instance, we correctly identifying McDonald's as fast food rather than real estate. Okay, this is our this is our POI Fusion framework. Thank you for your attention and time.